School of Management Studies IGNOU presents an audiobook on the course MMPC 010 titled Managerial Economics for MBA Program. Presenting Block 2 titled Demand and Revenue Analysis. Unit 6 Demand Estimation and Forecasting.
Objectives. By studying this unit, you should be able to identify a wide range of demand estimation and forecasting methods, apply these methods, and to understand the meaning of the results. Understand the nature of a demand function. Identify the strengths and weaknesses of the different methods. Understand that demand estimation and forecasting is about minimizing risk. Introduction. The first question which arises is, what is the difference between demand estimation and demand forecasting? The answer is that estimation attempts to quantify the links between the level of demand and the variables which determine it. Forecasting, on the other hand, attempts to predict the overall level of future demand rather than looking at specific linkages. For this reason, the set of techniques used may differ, although there will be some overlap between the two. In general, an estimation technique can be used to forecast demand, but a forecasting technique cannot be used to estimate demand. A manager who wishes to know how high demand is likely to be in 2 years' time might use a forecasting technique. A manager who wishes to know how the firm's pricing policy could be used to generate a given increase in demand would use an estimation technique. The firm needs to have information about likely future demand in order to pursue optimal pricing strategy. It can only charge a price that the market will bear if it is to sell the product. On one hand, over-optimistic estimates of demand may lead to an excessively high price and lost sales. On the other hand, over-pessimistic estimates of demand may lead to a price which is set too low, resulting in lost profits. The more accurate information the firm has, the less likely it is to take a decision which will have a negative impact on its operations and profitability. The level of demand for a product will influence decisions, which the firm will take regarding the non-price factors that form part of its overall competitive strategy. For example, the level of advertising it carries out will be determined by the perceived need to stimulate demand for the product. As advertising expenditure represents an additional cost to the firm, unnecessary spending in this area needs to be avoided. If the firm's expectation about demand are too low, it may try to compensate by spending large sums on advertising, money which in this instance may be at least partly wasted. Alternatively, it may decide to redesign the product in response to this, thus incurring unnecessary additional costs in the form of research and development expenditure. In the previous unit, demand analysis was introduced as a tool for managerial decision-making. For example, it was shown that knowledge of price and cross-elasticities can assist managers in pricing and that income elasticities provide useful insights into how demand for a product will respond to different macroeconomic conditions. We assumed that these elasticities were known or that the data were already available to allow them to be easily computed. Unfortunately, this is not usually the case. For many business applications, the manager who desires information about elasticities must develop a data set and use statistical methods to estimate a demand equation from which the elasticities can then be calculated. This estimated equation could then also be used to predict demand for the product based on assumption about prices, income, and other factors. In this unit, the basic techniques of demand estimation and forecasting are introduced. Evaluating the accuracy of the regression equation, regression statistics. Once the parameters have been estimated, the strength of the relationship between the dependent variable and the independent variables can be measured in two ways. The first uses a measure called the coefficient of determination, denoted as R square, to measure how well the overall equation explains changes in the dependent variable. The second measure uses the statistic to test the strength of the relationship between an independent variable and the dependent variable. Evaluating the explanatory power of individual independent variables. The t-test is used to determine whether there is a significant relationship between the dependent variable and each independent variable. This test requires that the standard deviation of the estimated regression coefficient be computed. The relationship between a dependent variable and an independent variable is not fixed because the estimate of b will vary for different data samples. The standard error of the equation is used to determine the likely accuracy with which we can predict the value of the dependent variable associated with particular values of the independent variables. As a general principle, the smaller the value of the standard error of the equation, the more accurate the equation is, and hence, the more accurate any predictions made from it will be. To put this in another way, the standard error represents the standard deviation of the dependent variable about the regression line. Thus, the smaller the value, the better the fit of the equation to the data and the closer the estimate will be to the true regression line. Conversely, the larger the standard error, the bigger the deviation from the regression line and the less confidence that can be put in any prediction arising from it. The standard error of the coefficient works along similar lines. It gives an indication of the amount of confidence that can be placed in the estimated regression coefficient for each independent variable. Again, the smaller the value, the greater the confidence that can be placed in the estimated coefficient and vice versa. Finally, the t-test provides a further measurement of the accuracy of the regression coefficient for each of the independent variables. A value of t greater than or equal to 2 generally indicates that the calculated coefficient is a reliable estimate, while a value of less than 2 indicates that the coefficient is unreliable. The marketing approach to demand measurement. The vast majority of business decisions involve some degree of uncertainty, and managers seldom know exactly what the outcomes of their choices will be. One approach to reducing the uncertainty associated with decision making is to devote resources to forecasting. Forecasting involves predicting future economic conditions and assessing their effect on the operations of the firm. Frequently, the objective of forecasting is to predict demand. In some cases, managers are interested in the total demand for a product. For example, the decision by an office products firm to enter the home computer market may be determined by estimates of industry sales growth. In other circumstances, the projection may focus on the firm's probable market share. If a forecast suggests that sales growth by existing firms will make successful entry unlikely, the company may decide to look for other areas in which to expand. Forecasts can also provide information on the proper product mix. For an automobile manufacturer such as Maruti Suzuki Limited, managers must determine the number of Swift versus Alto to be produced. In the short run, this decision is largely constrained by the firm's existing production facilities for producing each kind of car. However, over a longer period, managers can build or modify production facilities. But such choices must be made long before the vehicles begin coming off the assembly line. Accurate forecasts can reduce the uncertainty caused by this long lead time. For example, if the price of petrol is expected to increase, the relative demand for Alto or compact cars is also likely to increase. Forecasting is an important management activity. Major decisions in large businesses are almost always based on forecasts of some type. In some cases, the forecast may be little more than an intuitive assessment of the future by those involved in the decision. In other circumstances, the forecast may have required thousands of work hours and lakhs of rupees. It may have been generated by the firm's own economists provided by consultants specializing in forecasting, or be based on information provided by government agencies. Forecasting requires the development of a good set of data on which to base the analysis. A forecast cannot be better than the data from which it is derived. Three important sources of data used in forecasting are expert opinion, surveys, and market experiments. Expert opinion. The collective judgment of knowledgeable persons can be an important source of information. In fact, some forecasts are made almost entirely on the basis of the personal insights of key decision makers. This process may involve managers conferring to develop projections based on their assessment of the economic conditions facing the firm. In other circumstances, the company's sales personnel may be asked to evaluate future prospects. In still other cases, consultants may be employed to develop forecasts based on their knowledge of the industry. Although predictions by experts are not always the product of hard data, their usefulness should not be underestimated. Indeed, the insights of those closely connected with an industry can be of great value in forecasting. Methods exist for enhancing the value of information elicited from experts. One of the most useful is the Delphi technique. Its use can be illustrated by a simple example. Suppose that a panel of 6 outside experts is asked to forecast a firm's sales for the next year. Working independently, 2 panel members forecast an 8% increase. 3 members predict a 5% increase, and 1 person predicts no increase in sales. Based on the responses of the other individuals, each expert is then asked to make a revised sales forecast. Some of those expecting rapid sales growth may, based on the judgments of their peers, present less optimistic forecasts in the second iteration. Conversely, some of those predicting slow growth may adjust their response upward. However, there may also be some panel members who decide that no adjustment of their initial forecast is warranted. Assume that a second set of predictions by the panel includes one estimate of a 2% sales increase, one of 5%, two of 6%, and two of 7%. The experts again are shown each other's responses and asked to consider their forecasts further. This process continues until a consensus is reached or until further iterations generate little or no change in sales estimates. The value of the Delphi technique is that it aids individual panel members in assessing their forecasts. Implicitly, they are forced to consider why their judgment differs from that of other experts. Ideally, this evaluation process should generate more precise forecasts with each iteration. One problem with the Delphi method can be its expense. The usefulness of expert opinion depends on the skill and insight of the experts employed to make predictions. Frequently, the most knowledgeable people in an industry are in a position to command large fee for their work as consultants, or they may be employed by the firm, but have other important responsibilities, which means that there can be a significant opportunity cost involving in the planning process. Another potential problem is that those who consider themselves experts may be unwilling to be influenced by the prediction of others on the panel. As a result, there may be few changes in subsequent rounds of forecast. Surveys. Surveys of managerial plans can be an important source of data for forecasting. The rationale for conducting such surveys is that plans generally form the basis for future actions. For example, capital expenditure budgets for large corporations are usually planned well in advance. Thus, a survey of investment plans by such corporations should provide a reasonably accurate forecast of future demand for capital goods. Several private and government organizations conduct periodic surveys. The annual National Council of Applied Economic Research (NCAER) survey of market information of households is well recognized. Many private organizations like ORG, MARG, and TNS India conduct surveys relating to consumer demand across certain geographical areas. If data from existing sources do not meet its specific needs, a firm may conduct its own survey. Perhaps the most common example involves companies that are considering a new product or making a substantial change in an existing product. But with new or modified products, there are no data on which to base a forecast. One possibility is to survey households regarding their anticipated demand for the product. Typically, such surveys attempt to ascertain the demographic characteristics, example, age, education, and income, of those who are most likely to buy the product and find how their decisions would be affected by different pricing policies. Although surveys of consumer demand can provide useful data for forecasting, their value is highly dependent on the skills of their originators. Meaningful surveys require careful attention to each phase of the process. Questions must be precisely worded to avoid ambiguity. The survey sample must be properly selected so that responses will be representative of all customers. Finally, the methods of survey administration should produce a high response rate and avoid biasing the answers of those surveyed. Poorly phrased questions or a non-random sample may result in data that are of little value. Even the most carefully designed surveys do not always predict consumer demand with great accuracy. In some cases, respondents do not have enough information to determine if they would purchase a product. In other situations, those surveyed may be pressed for time and be unwilling to devote much thought to their answers. Sometimes, the response may reflect a desire to put oneself in a favorable light or to gain approval from those conducting the survey. Because of these limitations, forecasts seldom rely entirely on results of consumer surveys. Rather, these data are considered supplemental sources of information for decision making. Market experiments. A potential problem with survey data is that survey responses may not translate into actual consumer behavior. That is, consumers do not necessarily do what they say they are going to do. This weakness can be partially overcome by the use of market experiments designed to generate data prior to the full-scale introduction of a product or implementation of a policy. To set up a market experiment, the firm first selects a test market. This market may consist of several cities, a region of the country, or a sample of consumers taken from a mailing list. Once the market has been selected, the experiment may incorporate a number of features. It may involve evaluating consumer perceptions of a new product in the test market. In other cases, different prices for an existing product might be set in various cities in order to determine demand elasticity. A third possibility would be a test of consumer reaction to a new advertising campaign. There are several factors that managers should consider in selecting a test market. First, the location should be of manageable size. If the area is too large, it may be expensive and difficult to conduct the experiment and to analyze the data. Second, the residents of the test market should resemble the overall population of India in age, education, and income. If not, the results may not be applicable to other areas. Finally, it should be possible to purchase advertising that is directed only to those who are being tested. Market experiments have an advantage over surveys in that they reflect actual consumer behavior, but they still have limitations. One problem is that the risk involved. In test markets where prices are increased, consumers may switch to products of competitors. Once the experiment has ended and the price reduced to its original level, it may be difficult to regain those customers. Another problem is that the firm cannot control all the factors that affect demand. The results of some market experiments can be influenced by bad weather, changing economic conditions, or the tactics of competitors. Finally, because most experiments are of relatively short duration, consumers may not be completely aware of pricing or advertising changes. Thus, their responses may understate the probable impact of those changes. Demand forecasting techniques. Time series analysis. Regression analysis, as described above, can be used to quantify relationships between variables. However, data collection can be a problem if the regression model includes a large number of independent variables. When changes in a variable show discernible patterns over time, time series analysis is an alternative method for forecasting future values. The focus of time series analysis is to identify the components of change in the data. Traditionally, these components are divided into 4 categories. 1. Trend. 2. Seasonality. 3. Cyclical patterns. 4. Random fluctuations. A trend is a long-term increase or decrease in the variable. For example, the time series of population in India exhibits an upward trend, while the trend for endangered species such as the tiger is downward. The seasonal component represents changes that occur at regular intervals. A large increase in sales of umbrellas during the monsoon would be an example of seasonality. Analysis of a time series may suggest that there are cyclical patterns defined as sustained periods of high values followed by low values. Business cycles fit this category. Finally, the remaining variation in a variable that does not follow any discernible pattern is due to random fluctuations. Various methods can be used to determine trends, seasonality, and any cyclical patterns in time series data. However, by definition, changes in the variable due to random factors are not predictable. The larger the random component of a time series, the less accurate the forecasts based on those data. Trend projection. One of the most commonly used forecasting techniques is trend projection. As the name suggests, this approach is based on the assumption that there is an identifiable trend in a time series of data. Trend projection can also be used as the starting point for identifying seasonal and cyclical variations. Statistical curve fitting. Basically, this involves using the ordinary least squares concept developed above to estimate the parameters of the equation. Suppose that an analyst determines that a forecast will be made assuming that there will be a constant rate of change in sales from one period to the next. That is, the firm's sales will change by the same amount between two periods. Seasonal variation in time series data. Seasonal fluctuations in time series data are not uncommon. In particular, a large increase in sales for the fourth quarter is a characteristic of certain industries. Indeed, some retailing firms make large amounts of their total sales during the Deepavali period. Other business activities have their own seasonal sales pattern. Electric companies serving hot, humid areas have distinct peak sales periods during the summer months because of the extensive use of air conditioning. Similarly, demand for accountants' services increase in the first quarter as income tax deadlines approach. Exponential smoothing. Trend projection is actually just regression analysis where the only independent variable is time. One characteristic of this method is that each observation has the same weight. That is, the effect of the initial data point on the estimated coefficients is just as great as the last data point. If there has been little or no change in the pattern over the entire time series, this is not a problem. However, in some cases, more recent observations will contain more accurate information about the future than those at the beginning of the series. For example, the sales history of the last 3 months may be more relevant in forecasting future sales than data for sales 10 years in the past. Choice of a smoothing constant. Any value of alpha could be used as the smoothing constant. One criterion for selecting this value might be the analyst's intuitive judgment regarding the weight that should be given to more recent data points. But there is also an empirical basis for selecting the value of alpha. Remember that the coefficients of a regression equation are chosen to minimize the sum of squared deviations between observed and predicted values. This same method can be used to determine the smoothing constant. Barometric forecasting. Barometric forecasting is based on the observed relationships between different economic indicators. It is used to give the decision maker an insight into the direction of likely future demand changes, although it cannot usually be used to quantify them. 5 different types of indicators may be used. Firstly, there are leading indicators which run in advance of changes in demand for a particular product. An example of these might be an increase in the number of building permits granted, which would lead to an increase in demand for building-related products such as wood, concrete, and so on. Secondly, there are coincident indicators which occur alongside changes in demand. Retail sales would fall into this category, as an increase in sales would generate an increase in demand for the manufacturers of the goods concerned. Thirdly, there are lagging indicators which run behind changes in demand. New industrial investment by firms is often said to fall into this category. In this case, it is argued that firms will only invest in new production facilities when demand is already firmly established. Thus, increased investment is a sign or confirmation that an initial increase in demand has already taken place. This may well indicate that the economy is improving, for example, so that further changes in the level of demand can be expected in the near future. One particular problem with each of these three types of indicators is that single indicator does not always prove to be accurate in predicting changes in demand. For this reason, groups of indicators may be used instead. The fourth and fifth types of indicator fall into this category. These are composite indices and diffusion indices respectively. Composite indices are made up of weighted averages of several leading indicators which demonstrate an overall trend. Diffusion indices are a group of leading indicators whose directional shifts are analyzed separately. If more than half of the leading indicators included within them are rising, demand is forecast to rise and vice versa. Again, it is important to note that it is the direction of change that is the basis of the prediction. The actual size of the change cannot be measured. In addition, the situation is complicated by the fact that there may be variations in the length of the lead time between the various indicators. This means that the accuracy of predictions may be reduced. Summary. In this chapter, we have looked at a range of demand estimation and forecasting techniques which can be used by the firm either singly or in combination in order to predict the level of demand for their products. The choice of technique will depend upon the resources at the firm's disposal, the cost to the firm of insufficient knowledge of the markets in which it operates, and the ease with which information can be obtained. Each of the methods we have considered has its own advantages and disadvantages in its use, and there is no right or wrong approach in any given situation. It is for the decision maker to choose the techniques which are most appropriate to the firm's needs. As a general principle, however, the more accurate information the firm has, the better it will be to take the best decisions possible for the firm's efficient operation. Thus, the firm can substantially reduce the risk to which it will exposed, particularly in rapidly changing markets. Sales forecasts can be developed using qualitative methods such as expert opinion, the Delphi method, or market surveys, or by using quantitative models such as exponential smoothing, time series decomposition, or multiple regression analysis. In many cases, firms use a combination of qualitative and quantitative forecasting techniques. The use of more than one sales forecast method is advisable because doing so can reduce errors in the final forecast.
We were listening to the audiobook by the School of Management Studies IGNOU for MBA program. Course code Mmpc 010, titled Managerial Economics. Course Coordinator Dr. Leena Singh. Voiceover by Renuka. Edited by Savita. Program assisted by Tarannum Jahan. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.